Okay, so next, let's figure out how many kilometers it is around Earth's equator. How many kilometers around Earth's equator? Now, we could look that up on the internet, but that'd be no fun. So let's do it the interesting way. Now, the conversion factors we're going to use for this are nautical miles. That's the way we're going to go with it. Now, what's a nautical mile? How's that going to help us? Well, it turns out that 1 nautical mile is defined as 1 minute of arc. And I hear you asking, what is 1 minute of arc? Well, you've heard of 360 degrees in a circle? Well, if you divide each one of those degrees into 60 pieces, there are 60 minutes of arc in 1 degree. So if you cut a degree into 60 pieces, each one of those little pieces is called a minute. It used to be pronounced minute, which means very small. And then, purely for trivia, if you then cut a minute into 60 pieces, that's a second. It's a second division of something that is already minute. So there you go. And when they started making very precise clocks, they used the same terms, minutes and seconds, for small divisions of an hour and tiny divisions of a minute. But I digress. Bottom line here is that 60 minutes of arc makes 1 degree of arc. And a nautical mile is defined as 6,076 feet. It's actually slightly more than that, but we're going to go with 6,076. So a nautical mile, like we use in air navigation or for sea navigation, is slightly longer, well, significantly longer than a statute mile, which is 5,280 feet. So these are the basic conversions we're going to go, and I'm going to show you one more, which is really, really useful. One more conversion in this one. So we're going to start off with 360 degrees because the Earth equator is a giant circle, and we have divided into 360 degrees of latitude and longitude. And each minute, degree rather, is divided into 60 minutes. 60 minutes per 1 degree. And 1 nautical mile is 1 minute. Now we're going to go to feet because 6,076 feet per nautical mile, I'm going to abbreviate it NM. And as you know, there are 12 inches in a foot. And here's the useful one, and this is a conversion that I want you to remember because it's dead useful. 2.54 centimeters per inch. Okay, remember that one, because this is an exact conversion. This is the way you get from metric units to English units and back again. There's exactly 2.54 centimeters per inch. The United States actually redefined the inch in the 1950s as exactly 2.54 centimeters. So it turns out that since the 1950s, the United States unit of measures is based on the metric system. Who knew? Must be some vast communist conspiracy, but we're stuck with it. Anyway, 2.5400 centimeters is 1 inch. It was already very close to that, so it was not a major change. But yeah, they redefined the inch. 2.54 centimeters per inch, that will always get you from metric units to English units. All the other conversions that you get are approximations, like, 0.64 miles per kilometer or whatever it is, 0.67, I forget what it is. That's an approximation. This one's exact, so remember it. And finally, we'll finish up here with, let's see, 100 centimeters is 1 meter, and then 1,000 meters per kilometer. That's enough factors, and that should get us where we want to be. So, degrees cancel, minutes cancel, nautical miles cancel, feet cancel, inches cancel, centimeters cancel, and meters cancel. And it leaves us with kilometers, so we're good. Now let's get out the calculator and see what it turns out to be. We've got 360 degrees times 60 times 1 times 6,076 times 12 times 2.54 divided by 100 divided by 1,000. And we wind up with 40,002 kilometers. 40,002 kilometers all the way around the equator, which may strike you as a suspiciously round number, but remember, the French originally defined the meter as 1 million meters from the equator to the North Pole. And they were off by a little bit, but they weren't off by much, because if 90 degrees is 1 million meters, 360 degrees will be 40 million meters, which will be 40,000 kilometers. So there you are. Who knew? All right. Now, why am I showing you this bizarre example here? It's because even if you're not familiar with the units, you don't have to be. As long as you can figure out the conversion factors, as long as you can look up the conversion factors, you can set up your equations so that it will spit out the correct answer. You don't have to keep all these pieces in your mind. You can lay them all out in a long series here, checking as you go that the units are going to cancel, and it will spit out the right number. So 40K kilometers is our answer. And there you go. All right, so I do recommend that you practice these things so you can get to the same answers that I got. And as you know, there is a worksheet on the in the Google Classroom, so you can practice these things. I only want you to practice as many as you need to. This is a review, but there will be a quiz next week. In the second week of formal classes, where you're going to have to demonstrate all of these math skills that we have been reviewing here. So the whole 9 yards. Metric system, knowledge of units, ability to manipulate scientific notation, a little bit of trigonometry, and the skill of dimensional analysis. Okay, just in case you want to see it, let's do a stoichiometry problem, because I promised this. Now, you sophomores, this is going to be a preview for you, because you guys are taking chemistry this year and you're not going to see stoichiometry until later on. But let's do one of these, and you can hopefully see what I mean about stoichiometry is actually just a unit conversion process. So we're going to figure out how many grams of oxygen there are in 15 grams of carbon dioxide. So if we have a sample of 15 grams of the compound gas carbon dioxide, how many grams of that are actually oxygen? Okay, and here's how we do it. We use moles, and those of you who haven't learned chemistry yet may not be familiar with a mole, but we're going to go with it anyway. Okay, so we have 15 grams of CO2 in our sample. Okay, that's what we're starting with. And now we know that there are 44 grams of CO2 in 1 mole of CO2. Just in case you don't remember where I got that, we remember that carbon is 12 grams per mole and oxygen is 16 grams per mole. So 16 plus 16 is 32, plus 12 is 44, so 44 grams per mole of CO2. 44 grams of CO2 in 1 mole of CO2. Next, we're going to go with 2 moles of oxygen, 2 moles of oxygen in each mole of CO2. So C1 carbon, 2 oxygen. So if we have 1 mole of this stuff, 2 of those moles, we're going to have 2 moles of oxygen and 1 mole of CO2. So 2 moles of oxygen per 1 mole of carbon dioxide. Next, we go with grams, because we want to know how many grams of oxygen. So there's 16 grams of oxygen per mole of oxygen. And we're good to go. That's it. Because we have grams of CO2 canceling grams of CO2. We have moles of CO2 canceling moles of CO2. We have moles of oxygen canceling moles of oxygen. And we're left with grams of oxygen in our sample. There it is. So grams of oxygen. And we get out our calculator here, and we go 15 divided by 44 times 2 times 16, and we get 10.9 grams of oxygen in 15 grams of CO2. Viola, as they say in badly accented French. Okay, thank you for your time. We may have time in class to practice a couple of these if a lot of people are having problems with them. But yeah, that's our math review for AP1. Good luck with it, and we'll see you in class.